Hi, my name is Patrick Alvarez, and today my team will be presenting drive belt selection procedures. Um, we had to be concerned with four major belt types, which are round belts, V belts, flat belts, and tooth belts. Each of these belts has their own pros and cons and are used in many different applications, and each are mostly efficient in each application. Um, our first belt type is round belts. Um, one of their benefits is that they could be bent in any direction. Um, One of their cons, though, is why we don't see them in many applications, is because they can only be used in low torque applications. So when round belts are used, um, they get wedged in the 60-degree curve there, pulley. Um, when it gets wedged in there, they don't have as many contact points as other pulleys, so they tend to slip. And when they tend to slip, things happen that you don't really want to happen. Next. All right, here are the flat belts. They have a rectangular cross section, so that is good. Uh, the thinness of the belts uh, means the belts will be a little bit more flexible and efficient. Um, they were mainly used in the Industrial Revolution, and they're kind of rare now. And they required crown pulleys to be more reliable. So as you can see, the belts, they kind of curve at the end, so the belt won't jump off and things won't happen that you don't want to happen. All right, so as you can see here, leather flat belts used in the Industrial Revolution. That they had longer center distances, and you can see the distance between one pulley to another. Now, there are much new variations of the flat belt. Um, they are now made with ribs and grooves to have to make more friction contact. And you can see, they're mainly used in front of our engines on our vehicles to basically power, our fans, alternators, um, and everything in front of the engine. And these serpentine belts, they're basically, you can fit the whole system into a much smaller space, and they're very efficient. So now, give it to Brian.
V-belts are composed of rubber, typically reinforced with fibers or metal to absorb the tensile strength while it's tightened into the pulleys or in high power applications. The pulleys are designed with a V groove, the same shape as the belt, forcing the belt to wedge itself into the pulley and essentially pull it around while it's in motion. These can be efficient if designed correctly. If the groove in the pulley is too small, the belt will get stuck in the pulley and there will be too much force required to pull it out of the pulley and make it as low as 70% efficient. If designed correctly, they can be up to 98% efficient. They operate better at higher speeds, typically around 4,000 feet per minute, but if they're operating much higher, there will be many vibrations introduced and premature failure will occur. Because of the way the groove essentially pulls the pulley, there's not as much wraparound or contact area required to operate. So this allows the pulleys to be crammed in a small space and operate still efficiently. The pulleys can only be bent in one direction though, because of the way that they're designed. So because of this, they cannot be used for entire serpentine systems. There must be multiple belts involved. So for example, in an engine, if there are multiple pulleys in different planes, multiple belts must be used. Like if, for example, here there's two pulleys, one on one side, the other on the other side, because they cannot bend around one pulley and then up to another pulley. In very high power situations, a single V-belt may end up wedging itself into the pulley too far, similar to as if the wedge was too small. So to fix this issue, there are belts with multiple pulleys, multiple V's created to increase the contact area over multiple V's. Even then, if the power is too high for the pulley, for the belt, the high power will force the belt into the pulley too far and it will be very inefficient.
Tooth belts are more expensive than the other type of belts. They're constructed usually, they're always constructed of rubber, and they usually have steel filaments inside to support the tension load. Now, while they are more expensive than the other types of belts, they can carry higher loads, and more importantly, you can maintain an exact velocity ratio between the different pulleys in the system by using a tooth belt, because the teeth offer you a positive mechanical drive, and there will never be any slippage in the system. They have a very high torque capacity, and they're 97 to 99% efficient, which makes them comparable to a serpentine system. Also, you don't have to, because of the teeth, you don't have to tension them any more than is necessary to keep the belt from slipping off of the pulleys. Tooth belts are frequently used in a lot of the same applications where you would use a chain. However, you don't need to lubricate them unlike a chain, and they're much quieter. But like I said, they are very expensive. And if you go with the tooth belt, then you also have to go with tooth pulleys, which are more expensive than the regular groove pulleys you would use for other types of drag belts. Typical applications of a tooth belt would be to drive something like a supercharger, which requires a lot of power and would cause other types of belts to slip, or else to drive cams in a car's valve train, where you can't have any slippage in the system, where